All good?
Yes, all good.
Okay, perfect. So I'm going just to, as I said, I'm going to do a very quick recap. So what we were talking about, that basically DAGs are graphs that we can use where we can see all the links between our exposure of interest and our outcome of interest. And to be able to see or to estimate the causal effect of my exposure on my outcome, I need to block, in quotation block, this is the terminology they use in DAGs, or the non-causal paths. So I don't know if you remember this famous DAG that we used last time as our reference. So as a recap, let's do this together. I'm just gonna move to the next slide. Okay, so if I have, so I want to see the effect of my exposure on my outcome or disease. First of all, I would basically have to identify all the paths from E to D. And then I'll see if in one path I have a collider. So would I consider this path to be causal or non-causal path?
Non-causal.
Non-causal, perfect. So should it be blocked because it's non-causal?
No, it's automatically blocked, right?
Okay,
Collider.
Yes, perfect. So, I mean, it should be blocked, but how to block it? It is automatically blocked. This is correct. So we all agree that if you have a path with just a collider, it's a non-causal path that should be blocked. And how to block it? It's already blocked because it's a collider, unless, of course, we condition or adjust for a collider. Perfect. Let's see if you have a path with the confounders, or what we call the backdoor path, which means that the arrow points to the exposure. Is it a causal or non-causal path?
Also non-causal.
Okay, should it be blocked?
Yes.
And how can we block it?
We have to adjust for the confounder.
Okay, or any variable on the backdoor path.
Yes.
Okay, we all agree on this. Perfect. The third case, it was when I was talking about the M-shaped bias. So if you have a path where we have both a collider and a confounder, so it is a backdoor path with a collider in it. Is it a non-causal or causal path?
Non-causal.
Non-causal, perfect. Should it be blocked, and how can we block it?
It should be blocked, but it's automatically blocked because there's a collider.
Perfect. So that's when we were talking about the M-shaped bias, that basically, even if we have confounder, the fact that we do have a collider, the path is automatically blocked. We do not need to adjust for the confounders in this backdoor path. So this is a special, if you want, case of the option B. Great. Now we have a mediator of the effect of E on D. And I remember last time someone asked me about, I'm going to go back on this idea about if we have a mediator that wasn't directly linked to the exposure and the outcome. So here we're talking about the mediator of the effect of E on D. So is it a causal or non-causal path?
It's causal.
It's causal. Should it be blocked, and how should I block it?
No, we should not block it.
Okay, perfect. So we should not block it unless we want to see the direct effect, but otherwise we should not block it. Perfect. Now here, mediator in a non-causal path. So I remember last time there is an interesting question about G, that G is basically a mediator between C and D, but G is basically in a non-causal path. So E, C, G, D is a non-causal path. And so I was saying that it doesn't really matter, because at the end of the day, this is a non-causal path, and it's not, G is not the mediator between E and D. And then someone else asked me about the collider. I said it's different, because I mean, what I want to see is all the paths from E to D. If I have a non-causal path, so if I have a collider in one of the paths, so this is a non-causal path that I need to block. Here also E, C, G, D, it's basically a non-causal path because we have a confounder C, so I need to block it. But E, M, D is a causal path, and M is the mediator, so I do not need to block it. So this is the difference. So here, if we have a mediator in a non-causal path, so like G in our case, it's still a non-causal path, and we should block it. And we block it depending if we have a confounder or collider, or if it's collider or confounder. So here, just to clarify that when we talk about mediator of the effect of E on D, we're talking about causal path that should not be blocked. But if we have mediators on other variables that are not directly E and D, but are on non-causal paths, I don't care. I anyway need to block this path because it's a non-causal path. Is it clear at the concept?
Yes.
Okay, perfect. And of course, the most important things to know is now we're talking about very easy paths when we have just one, each variable is just linked to one path. But as we said last time, we could have it could be a collider in one path and a confounder in another path. This example, so X3 is a confounder in the path T, X3 and Y. Let me just get this. So T, X3 and Y, this was a confounder. And so we need to adjust for it. But in another path, which is T, X2, X3, X1, this is a collider. So just for you to keep in mind that the same variable could be a collider in one path and a confounder in another path. And the way I have to proceed is basically step by step, so path by path. I go to be able to make sure that I blocked all the non-causal paths. So far, is it clear? Do you have any additional question, or is it all is clear?
I have a question with this one.
Sure.
So last time we adjusted for either X2 and X3 or X1 and X3. Is this because it's a NAM path or because X3 is a confounder in this case?
Because in this case, when we, because X3 is a confounder, that's why, not because it's a M, because X3 is a confounder in T, X3, and Y, I'm obliged to adjust for it. I have no choice because I want to block T, X3, and Y. The only way, I'm just gonna get the pen. So this path, the only way I can block it is basically by adjusting on X3. And because I'm doing this, I'm opening, because this is a collider in T, X2, X3, X1, and Y, which is the M, as you said, the M shape. I'm adjusting on X3. So it's in this case, as if I adjusted on this variable. So what would happen? It will open here a path. It doesn't matter the direction. Sorry?
We would create a fake association between X1
exactly,
and X2.
Exactly. It would create a fake association between X2 and X1. So I have an additional path, which is T, X2, X1, Y. That didn't exist before. I remember someone asked me, I'm not sure if it's this class, but someone asked me, what is the direction of this path? Actually, it doesn't matter because it's a fake one. So you have to count it out to consider it as a non-causal path. It's a fake association. And to be able to basically stop this new path, which is this one, to stop it, to block it, it's a backdoor path. And the way we block backdoor paths is basically by adjusting on one of the variable in the backdoor path. So either X2 or X1. And this is why we need to adjust for X3 and X2 or X1. Does it make sense?
Yes, it does. Yes, thank you.
Okay.
Doctor, just one question.
Yes.
Isn't it enough to adjust only X2 or X3? Why both of them? Yani X2 and X3?
No, because you can't adjust just for X2. Okay, because let's try to do it together. If I just, right, your question is why do we need to adjust for both? Why not just X2, right? Or just X3?
Yes.
Okay, so we said that we cannot adjust just for X3 because if we do, I have this path, which is T, X2, X1, Y, that is still open. I didn't block it because I just blocked this one. I blocked this one. I'm sorry. I blocked this one by adjusting on X3. Okay, but this one, I mean, and this one, T, X3, X1, Y is already blocked because I adjusted on X3. You remember there were 5 paths here, if you remember. So I need to block all these paths, but basically, I'm sorry, because I'm writing it. So when I adjust on X3, the first one is blocked. The T, X3, X1, Y is blocked. So this one is blocked because I adjusted on X3. I adjusted on one variable of the backdoor path. So this is done. Then we have the other path, which is T, X2, X3, Y. I'm gonna use another color. Let me just, Okay, so I adjusted on X3. I blocked T, X3, XY. We all agree on this. Then I have the second pass, which is that's it, which is T, X2, X3, Y. This pass, this road, if you want, it is a backdoor pass. I need to adjust on one variable in this pass. I already adjust on X3, so it's good, we're good. I don't need to do anything else. So this pass is also blocked. So let me, I don't know why it's not erasing. Okay, now I still have, what else as pass? I still have the T, X3, X1, Y pass. This pass is also a backdoor pass. So in a backdoor pass, I need to adjust for any variable in the backdoor pass. So just to remind you, it's a backdoor pass because the arrow is pointing toward the exposure. So also I already adjusted on X3, so this pass is closed. I don't have any more problem with this pass. So this is done. What else I have? I have the M1, the T, X2, X3, sorry, X1, Y. So this one, it used to be blocked, right? Because if I didn't adjust for X3, it was already blocked. But because I adjusted for X3, so I opened a new pass, which is this one. T, X2, X1, Y. So this pass is a non-causal pass. We all agree because it's a backdoor pass, the arrow is pointing toward the exposure. And anyway, it's a fake association because as we said, when we adjust for X3, it will create a fake association. So this is a pass that I need to block. In your opinion, if I adjust on X3, would that pass T, X2, X1, Y be blocked or no?
No.
No, exactly. So I need to block it. And so in addition to X3, I need to use another variable, any variable on this pass, which is either X2 or X1. So that's why I need to adjust for both variables, X3 and X2. So I cannot just use X3. And the opposite is also correct. If I just basically adjust for X2, okay, I would basically block, for example, T, X2, X3, and Y pass, but I would still have this pass, T, X3, Y, that wouldn't be blocked. You agree? Because I just adjusted on X2. So this is a confounding pass, a backdoor pass that is not blocked. Do you agree?
Yes.
So that's why, in addition to X2, I need to adjust for X3. So to be able to get the direct effect of T on Y, I need to adjust for both X2 and X3 because you always have to see, you have to look at all the paths and make sure that all the non-causal paths are blocked. If you still have just one non-causal path that is not blocked, you still have a bias. So you have to make sure that all the non-causal paths are blocked. So if I just adjust on X2, I will still have one path that is not blocked. And the opposite is true. If I just adjust on X3, I will still have one path that is not blocked. This is why I need to adjust for both. Is it clear?
Yes, thank you.
Okay, perfect. Any other question?
Yes, please.
Sure.
The previous table,
yes.
It was like the third one. If we have a collider and the confounder at the same time.
Yes.
This is not the case of what we were explaining before, because this is two different, and each one is different than the other, right?
Yes, exactly. This is actually like this when we have a backdoor pass. So here we have a confounder, which is A and B, and we have M, which is a collider. So we have a backdoor pass with a collider. In this case, I don't need to do anything. Yes, correct. Okay. Here, the issue is that it's the same variable X3 that is in one pass a confounder and one pass a collider. It's totally correct what you said.
Okay, thank you.
Okay, perfect. Just to make sure, it's going to be a very quick recap. I think you've all got the point, but just to make sure that everything is clear. So let's look at the pass ECGD. So you remember last time you told me this is a non-causal pass because C is the confounder. It's a backdoor pass. You all agree about this, right? Because we have C, which is a confounder. It's a backdoor pass. The arrow is pointing toward the exposure, which is E. Okay, so let's play a little bit. if the arrow was E pointing towards C. So the path ECGD would be what?
A DAG.
It would be a causal or non-causal path?
Causal.
Okay, perfect. It will be a causal path, and C and G would be the mediators of the effect of E on D. And in that case, I should not adjust for it if I want to have the total effect, of course. If I want to have the direct effect, I would need to adjust. Perfect. Let's play again. If you have E, C, G, D, and you have the G, the arrow is pointing towards C. So would it be a causal or non-causal path? What do you think?
Non-causal.
Non-causal,
I think.
So in case I just changed, so what I did is, sorry, I changed the arrow from C to G. Here you have C pointing toward G, and then here I change it. So we have E pointing towards C, and then we have G, C, D, okay? So this path, E, C, G, D, is it a causal or non-causal path?
Non-causal, it's a collider.
Perfect, that's it. So it's a non-causal path, and C would be a collider. Let's play again, just to make sure that everything is clear. If now I have this type of arrow, this is it's a tricky one. So ECGD would be what?
Confounder?
Okay, what would someone else, what do you think? But how did you see the confounder? You have...
It's a mediator, the other way around, from D to E.
Okay. Do you remember what is the definition of DAGs? Directed acyclic graph.
صار عندنا cycle هون.
Yeah.
Perfect, exactly. So actually this is impossible in a DAG, because in a DAG, as we said, it should be acyclic. You cannot have those loops. And this is basically if you draw this kind of DAG, you're not following the DAG's rule. So this you should not, you couldn't have this case scenario in a DAG. So that was like a little bit tricky question. Okay, is it clear? And anyway, if you look at it, so you cannot have like the outcome that is causing the G, which is causing C, which is causing the exposure, and the exposure is in the past causing the disease. So that's why we cannot have a loop. Okay, so it's not about causal, non-causal. This path is impossible to be, this case scenario is impossible in a DAG. Okay, is it clear?
Yes.
Okay. So what I wanted to do, because last time we didn't really have time to work on it, is I really want you to use the software, because I really feel it's going to be very helpful for you, for your thesis or your research project later on. So I'm going to share again the link. Just open it, and I have an application, an example. I'm just going to use the other one. Okay, I'm going to use another application that you can draw on the DAGs, and you're going to tell me what is a set of variables that need to be adjusted. Don't do them manually, just do them through DAGs, okay? Let me first stop sharing and share the link, okay? Let me do this. Okay, I've sent the link. Just if you can all open it, and we can work on it. Okay, I'm going to open it again too. And I'm gonna share again my screen so you can see. Okay, let me know if you're being able to see my screen, which is basically the software.
Yes, very.
Okay. And did you all open the software? Were you able to open it on your computer?
Yes.
Okay. Great. So just how we use it, you just need to click on model and you put new model. So because we're going to start something new. Okay. And you see here we have on your left, you have variable, just open it. And then the way we use this, the DAGs, the software, so basically to add any variable, you just need to click on the screen. So I click on the screen and I can add any variable. So let's say it's x1, okay? And I say, okay. I want to add another one, I put x2. This is just to show you how we use it. And then you're going to use it with a real example. And this is x3. Okay, so these are the three variables. Let's say that I want x1 to be my exposure. So I click on it. So I click on x1. And then here, where you have variable at your right of the screen, you put that it's exposure. You select its exposure. So it will be in green. And then if I take x2 is the outcome, I click on it and I select outcome. It will be in blue, it will be the outcome. Okay. And then able to do the link, draw the arrow between each variable. It's very easy. So I just click, let's say that I want x1 is the cause of x2. So I click on x1 and then I click on, and as you can see, you have the arrow. And if I want to remove it, I just click on x2, sorry, I click, click again on x1 and I re-click on x2, I remove the arrow in case it's wrong. Now, something in here in the DAG is that you can actually draw two direction arrows, but as in a DAG, it's not correct. If you want a typical DAG, it's not correct. There are some articles that are using double direction arrows, but that's not dealt with. So for example, if I put x1 to x2 and then x2, x1, if you can see, as you can see, you can have here two arrows, but in our case, we're not going to go into this. Okay, so I'm gonna iterate. And what else I want to tell you? So this is the arrow. Let's say that x3 is the confounder. I put x3 is linked to x1 and x3 is linked to x2. So you can see it is in pink. So everything that is green here, I'm going to remove this. So you have here the causal path. Everything that is green, it means that it's a causal path. And everything that is, I don't know, pink, reddish, is basically a biasing path or a non-causal path. So here you can see that x1 to x2 is the causal path, which makes sense, the direct effect. And x1, x3, x2, which is in pink, is a non-causal path, the biasing path. And to know which variable you need to adjust for, you just have to go to the top right of your screen. You have here the effect identification. You have adjustment. You have, if you click on the arrow, you have either effect or direct effect. Don't look at the instrumental variable. It's something more complicated that we didn't talk about. So the total effect, it's everything. And now the total effect and direct effect would be the same in case we don't have a mediator. If we have a mediator, the total effect is basically without blocking the mediator, and the direct effect would be if I want to block the mediator. For the time being, let's look at the total effect, which is basically if we just want to block the non-causal path. So you have here, they tell you the minimal sufficient adjustment sets for estimating the total effect of x1 on x2 is x3, which is basically makes sense because it's a confounder. Okay. Is it clear? So I'm just going to give you an example that you can draw on your DAGs and let me know what the variable that needs to be adjusted. Okay, sounds good?
Yes.
Okay, I'm just gonna share again the example. It's my Zoom, share screen. Okay, so let's do this. No, sorry. It's this one. Okay, so this is an example. You want to see the effect of dark green vegetable intake to stomach cancer. And you have all these variables, knowing that you have two unmeasured variables, which is our allergies and risky behavior. So these are two variables that we were not able to measure in this study, whether because we can't measure them or because the researcher forgot to measure them. So based on this DAG, what is the minimum set of variables we need to adjust for to estimate the total effect of dark green vegetable intake on stomach cancer? So you can do them manually, it's gonna take time. So try to do them just on the DAG, just to get familiar with the application, and then let me know what is the result. I'm just gonna give you 5 to 10 minutes to do it. Okay.
Okay.
Great.
هلا it showed me that we have to adjust for age only to have the total
So
effect.
that you need to adjust for
Age.
Okay, just age you have.
Yes.
Okay.
I tried to draw the same
Yes.
DAG.
Okay. So you all agree, you all had the same results?
We still didn't finish.
Okay, sure. Okay, just one more minute and then I think we can continue.
I got age and risky behavior.
Okay, so risky behavior and allergies, you have to put them as unmeasured variables. So when you have exposure outcome, you remember you have in your on your left, you have the variable exposure outcome and you have unobserved, I think, variable. So you have to put them both as unobserved or measured. I forgot it's in the package because basically we're not able to measure them. And you got risky behavior.
Yes, now it worked. It gave me age only.
Okay. Okay, so I think most of you who basically were able to do the DAG, you should have indeed just one variable, which is age. So this should be your DAG. As you see, allergy and risky behavior should be unmeasured, so it's a light gray. And if you see, we have just one causal path, and all the non-causal paths, either they're all confounded by age, so it's just sufficient to just adjust for age to basically block all these paths. And one other path that is already blocked, which is basically when we have the one with alcohol intake. So these are basically two paths that are already blocked by the collider alcohol intake. And at the end, as you already said, we only have to adjust for age. And I want to use this example because if you did draw your DAG and you have all this variable, you would, if you don't really have a clear conceptual framework in DAG, you might think that, okay, I need to adjust for all this variable. I need to adjust for age, for alcohol intake, for smoking, to be able to see the effect because somehow they are associated with the exposure and the outcome. But we just saw all that when we basically draw the DAGs, we just need to adjust for age. And on the contrary, if we adjust for alcohol intake, because it's a collider, we will create bias. Okay, is it clear? Did someone face any problem or using the DAGity software, or is it clear for everyone?
It's clear for me, but when I did my DAGs, I did not set risky behaviors and allergy as unobserved, and still I got only age. So if
okay. So basically, maybe logically it should just be age because it's because even if we don't, because it's the only one that is the main confounder. So I think the person who told me that she got risky behavior, just double check if you draw your DAG exactly the same way, because it should just be age. Maybe you can try it later on, but it should just be age, regardless if risky behavior is measured or unmeasured. Okay. Anyway, if it didn't work, you can text me later and we can see what is the issue. But I think it should be like maybe it's one arrow that you forgot to draw or something like this. Okay, is it clear for everyone?
Yes, doctor.
Okay. So now I still had one application, but I'm not sure that I wanted you to do it like maybe manually, but I think because we don't have a lot of time, let's stop everything related to DAGs and move to the validity and reliability session. But basically, if you want, I'm going to keep this application on the on Moodle. So if you want, you can do it, and here you have the correction. And also we have another application about you drawing a DAG that you can actually also, if you want to train and try to do it. Okay, so that's it. So this is for DAGs. I hope more or less that it was clear, that you feel more comfortable with the concept of DAGs. Okay.
Doctor, I have a question.
Yes, sure.
The DAGs doesn't give us the magnitude of the association. بس بتقلنا إذا it's
yes,
confounded.
Exactly, true. So actually, I was just talking about DAGs as it's like very useful, etc. But basically, DAGs, yes, they do have quite some limitations. One of the limitations, as you just said, that we don't. I think my connection is so that you're not being able to use a magnitude. So they don't tell you actually to what extent variables are associated, if they are associated, and they don't give you the direction. So you don't know if it's a positive or negative association. So for example, I'm just gonna give you, let's go here. So for example, we have alcohol intake, risky behavior, and alcohol intake. So we know that increase in risky behavior will be linked to an increase in alcohol intake, but in the DAG, you don't see this association. You don't know if it's positive or negative. This is a limitation. Plus, as you just said, we don't have the magnitude. We don't know to what extent this association is strong or not. So this is totally correct. Okay. And in the article that I've actually posted on Moodle, there is one paragraph that talks about all the limitations of DAGs. And basically one of this limitation, they mention the magnitude and the direction, or actually not the direction of the arrow, because, okay, so you have cause and effect. This is a direct that age, for example, causes risky behavior, or that risky behavior can cause alcohol intake, but they don't tell you if it's causing it a positive or negative. Did you see there's a difference? Yes. Is it clear?
Yes, it's clear, but I think the reason because we're not giving this software any information. We're just saying that we have two variables and we're drawing arrows. So we're not giving any information about the level of exposure or the magnitude of the outcome. So it's normal that we will not. Yes, exactly. Yeah.
Yes, totally. Totally. And here the concept of DAG, no, you don't show this, but some people would basically consider as a limitation that you don't. I mean, when you have a DAG, you're not really looking at the magnitude. You're not really looking at the direction. You're just, as you just said, putting variables, putting arrow, and adjusting based on it, without really taking into consideration direction or magnitude. But still, it's a very useful tool, and even if it doesn't include, or it doesn't show you the magnitude, it doesn't show you the direction, it's fine. I mean, you can write them down later on. But as a DAG, it's a graph. It doesn't show you this if you want a feature or characteristics. But still, it's a very useful tool. I totally agree. And the software in DAGity, you cannot put the magnitude, you cannot put the sign, because it follows the rule of DAGs, which basically don't include those information to be able to identify the variable or the set of variables that you need to adjust for. This is how DAGs work.
Sometimes when we do the analysis, especially when you are creating regression model, so sometimes we suffer in putting variables in and variables out, and we test for the goodness of fit and the significance of the model, of the regression model, when you want to adjust for variable. So I think this is very helpful, so we can limit ourselves to one or two variables.
Exactly.
In our model, yes.
Exactly. This is different than the statistical approach. So the statistical approach is basically you take the variables that you think are confounder, you look at them, you see in the univariate, you do the univariate models, you see those are significant or more than 0.2, you put them in the multivariate analysis. So this is some of the rule of thumb that we used to do if we look at the statistical approach. So I look at my variable confounders, BAML univariate analysis, prove those that have a p-value more than, let's say, 0.2, then I put them on the multivariate model. In DAGs, you don't proceed. It's a different approach. Everything should have a rationale. You draw your DAG, you see what are the variables that needs to be adjusted for, and you put them on your model.
Okay,
So
we
it's
can
a different
do.
approach.
So yeah, I'm sorry, but no,
Yeah.
we can use that. We can explain our regression model. For example, we included only 2 variables, and we can explain this in the article by saying that we draw DAGs, and the minimum variables to get the total association is only 2 variables or 1 variable.
Yes, exactly. And if you want, there are a lot of articles who did this. I mean, of course, when you want to do, you discuss with your mentor or your advisor, what is the best approach. But yes, this is one of the approach when you use DAG. And I want to just show you again the article. Let me share again the other. I'm going to share my screen. Okay. Okay, are you being able to see my PowerPoint now?
Yes.
Yes.
Okay, so I'm going to actually post on Moodle this article, which is a very good article published in a very good journal, which is JAMA Pediatrics. We talked about it last time, the association of atopic dermatitis with sleep quality in children, and it's quite recent, and it was published in 2019. And the whole they use the DAGs, so they basically their figure 1 was the DAGs, and this is how they justify their model and what are the variables that they included in their model. So I'm going to also put this article on Moodle. So in case you want to follow this approach, the approach of DAGs, you can look at this article, how they did it, how basically they justify, how they explained it. And for your, your research or your future project, you can basically follow the same, the same rules if you want. This is one approach, or you can do the more traditional approach, which is basically do the univariate and look at and see those that are significant, put them in the multivariate model. That would basically depends on the discussion with your mentor or your advisor.
So I have one final question. Can we do the yes? Can we do the univariate analysis, and then we can create our DAGs based on the univariate analysis?
Yes. But based on univariate, do the DAGs? No. Your DAGs should be okay. So if you remember, we said that DAGs should be in the very early stage of your research.
Yes, I know. I remember.
Yes, you shouldn't be influenced by doing your analysis, your statistical result, and based on your statistical result, that wouldn't be correct, because it's purely, it should be purely based on the rationale behind it. You do DAGs, you make sure that your DAGs make sense, regardless of the statistical output that you will have. And then you do your analysis, because, if you're doing first your statistical univariate and you see that these 2 variables are linked somehow, or you have a kind of an association or signal association, you cannot change your DAG based on it. Your DAG is based on the rationale, it's based on the theory. And then you adjust based on this theory. Because sometimes, numbers at the end, statistical numbers could be biased. So you cannot, I'm not sure if I understood your question correctly, but you cannot fix or adjust or change your DAGs based on your statistical results. You do your DAGs, and here there are, but several people would do different things, because I know someone who basically draw DAGs and then they put the variable in the set of variable, they put it in multi-level model, regardless of the univariate. So even if, let's say, age was not statistically significant in the univariate, because in the DAG, you need to adjust for it, they put it in your model. And this is the concept, this is the right approach. Other people would basically try to, they do the DAG, we need to adjust for, let's say, age and 2 other variables. They also do the univariate just to double check, and then they put it in the model, in the multivariate. So the approach might differ, but if you really want to follow DAGs, it's regardless if it's significant or not significant on univariate. If you need to adjust for it based on the DAG, you need to put it. I'm not sure if I make sense what I'm saying, but what I'm trying to think that say that in a DAG, it's theory. So you have to adjust for age, let's say, and alcohol intake. I'm just giving an example. So in your multivariate model, you put age and alcohol intake, regardless if basically when you vary it, it will be significant or not. You see what I mean?
Yes, I got your point 100%. But here my question is, what if we are conducting a research in a specific context, which is not fully not fully مثلا covered in the literature. So and then we did our univariate analysis and we saw that we have a significant association. Based on the literature, it's not mentioned because we are doing a research in a special context. So should we adjust our DAGs?
Okay, I see your point. So you're talking about, for example, you have two variables, and basically in the literature, no one really were studying the relationship or the association between these two variables. And when you were doing your analysis, you discovered that basically they are linked, something like this, right? This is your question. Yes. Okay. Yes. Now, I mean, before to do, I mean, why did you do the statistical association? Because it should have a rationale. And if you discovered in quotation that these two variables are quite linked statistically, there must be some rationale behind it. There must be some theory behind it. Even though, I mean, I'm drawing my DAG and I have two variables. I don't have other literature about the association between the two variables, but I can do a guess. I mean, if I'm in the context, let's say something related to refugees, okay, and no one really looked at the association between these two variables. But me as a researcher, it's an assumption. I can do the hypothesis that, okay, I think that these two are basically linked. So I could put in the DAG this assumption, even though that it's not from the literature. I can just say that this is what we as experts we discussed, or I mean, a group of researchers discussed, and the hypothesis that these two are linked. You can put it like this in your DAGs, and then you can verify when you do your analysis. This is a very special case, but always remember that don't change your DAG based on on your statistical results. Never do this. From the beginning, if you have this theory or if you have this assumption, or if you think that, okay, these two variables might be associated, put it from the beginning in your DAG. Don't change it later on, because this is not how things should work. The whole point of DAG is that it should be independent. It should be like in the very early stage. You should draw your assumption before being any way affected by the statistical results.
Yes, all clear. Thank you.
Okay. Any other question for the DAG? But anyway, if you even later on, if you have any research or any project, whether it's in this master or if you want to, and you have any question, Ranja, don't hesitate. You can email me. I'm going to send my email and ask me any question about it. I can give you interesting resources about DAGs. Very simplistic way to introduce DAGs. It can really get way more complicated. There are effect modifier. You have, especially when you have, for example, DAGs in time. So it's a cohort, so you can have the same exposure at time 0, at time 1, at time 2. So it can really get way more complicated. But this is just, a very introduction to DAGs to make it more smooth, and so you can grasp a little bit concepts. But for later on, if you have any question, please don't hesitate to email me. I can send you a lot of resources, very interesting resources about DAGs.
Can I make a quick comment, please?
Yes, sure.
Okay, so two things. One is, and I see DAG, as you rightfully put it, as theoretical framework for any research study, at the research study. So instead of just writing about what are the variables that are related, is to graphically show the relationship, because it helps us understand relationship, right? So theoretical framework, or what we call conceptual framework, that you test when you collect the data, that it might work, it might not work. But what I like about the discussion also is how you see the biostat with the epi. And Kamena Nihad is saying how you a biostatistician, or maybe in the 313 or any biostat, how they proceed with the analyses compared to how we're thinking about it right now, right? So I think it's the way your DAG should direct your analysis, right? But analysis always is systematic. Yeah, it goes from descriptive to univariate or bivariate, that we call it, to unadjusted association to adjusted association. So the process is the same, but how you see, I mean, understanding the nature of the relationship is different. So they don't talk about effect modifier. They talk about interaction term, how to assess interaction. We put that interaction term in the analysis. So I think you as an epidemiologist should direct a biostatistician or how you do your biostat, but based on a priori and not a posteriori, right? So it's an a priori framework, or seeing how the word runs, and then this will direct. I'm not saying we are in discordance between the two, but I mean, it's a different way of seeing things, right? But I think it's you, the designer, you, the conceptual person who try to understand the relationship using all the stat tools. Thank you. That was very interesting, Anjad. Thank you for this practice exercise.
Welcome.
And I will excuse myself, and
yes,
I'll put you the host, okay?
Okay, sure.
Thank you.
We're going to move anyway to the other topic. Okay, so I'm just gonna share again my screen, and now we're going to move to validity and reliability. It's also going to be application exercises just to make sure that you understood the concepts. Okay, I'm just gonna share again my screen. Okay. Okay, you're being able to see my screen?
Yes.
Okay. Before starting, I'm not sure because I know it was a very long weekend. Friday and Monday were off. So I'm not sure if you had the time to actually look at the recording and listen to it. يعني في منكم قدروا يشوفوها أو لا؟
Yes, I was able to listen to it.
Hello?
Yes.
Yes.
Basically, I did not. We were busy.
Okay, you were busy. Okay, no problem. Okay, so basically, I mean, I expected that a lot of you have. I mean, I think now it's also your exams period. But what I'm going to try. Okay. Okay, thank you, doctor, for the message sheet. Okay, so what I'm going to try to do, it will first really try to later on, if you are interested in validity and reliability, which is basically related to scale development, read the words recording. So it's my colleague Sarah Al-Omari who did it, and it's very, very neat, very well explained, very smooth. So when you have, I mean, it's 1.5 hour, but actually you have like half an hour that is just, you know, when you like all the recordings in Zoom, you have like some time at the beginning, at the end, we're just like wasted time. So it's more or less like 60 minutes as a recording.
Yes, sure. يا أندريه صرت أنت الهوست. أندريه.
يلا, should I kick everyone out?
أندريه.
So
صرت أنت الهوست.
أنا
أول شيء
أنا الهوست.
هي أول شيء وقت اللي سكتت يعني إنه مبالي إنه هي عم تستنانا إنه لا يس we will watch the recordings. فشفت الكل سكت. قلت لا يس. طلع هي فصل عندها.
على فكرة it's still recording.
عادي.
I'm sorry, I'm back. I had an issue with الكهرباء, so it came back. Okay, so what I was saying is that because I know that maybe most of you didn't have time to look at the presentation, I've prepared some slides like exercises, application. I will actually take the opportunity to explain the concept at the same time. So it's going to be quite quick. So I think that most probably we're going to finish ahead of time. But as I said, I hope you heard me because I wasn't sure, Emata, I just got disconnected. What I was saying that later on, if any one of you is interested in scales and validation and reliability of scales, please look at the recording of Sarah Al-Omari. It's very well explained. It's very smooth as a recording. And here, basically, it's 1 hour, not 1.5 hour. Okay, so I'm gonna share again my screen. Okay. So first of all, do you know, okay, we're talking about validity and reliability when we talk about scales development, okay? Let's start with this. Can you tell the difference, I mean to guess, because I know you didn't look, you didn't see the recording. So can you tell the difference between the construct that are in blue, to those one, versus those that are not? So what is the difference between this construct and this construct? Just read them and just try to guess.
The ones in blue cannot be measured objectively like the ones in black.
Okay. Do you all agree?
Yes.
Yes.
Okay, perfect. So, I mean, when you talk about fever, overweight, obesity, systolic blood pressure, cholesterol, blood pressure, these are basically, as you said, I mean, tangible. You can measure them. For example, fever, you have the thermometer, more than 37 degrees, you know that you have a high, you have fever. Whereas when we talk about self-esteem, intelligence, stress, depression, quality of life, these are what we call latent construct because they are abstract construct because you cannot measure them in one item. I mean, how can I assess, for example, if I want to assess the cholesterol level in one of you, I can take the blood sample. I look at the cholesterol and I know that the cutoff is 200 milligram per deciliter. Everything that is higher than 200 milligram per deciliter, I said that, okay, this person have high cholesterol. But how can I know if this person has low or high self-esteem? I cannot just ask him, do you have low or high self-esteem? And the person would say yes or no. I cannot measure it by one item. So these construct, as you said, they are abstract. We call them latent construct, and they cannot be measured with one item, okay? And this is why we use what we call scales, which are basically a package of several items to be able to measure these abstract constructs. Now, how we measure scale, how we develop scale is something very complicated, or not complicated. I mean, it's a long process. And anyway, we're not going to delve into it. In the recording or here, we're not going to talk about it, okay? I just want to say that this slide, I took it from Dr. Randour's course. Okay, now, what do we mean by scale? So I'm talking about self-esteem, and I'll have to do a scale about self-esteem. So in this scale, I have several items, right? Or several questions. Actually, before proceeding, do you know famous scales or scales? Are you familiar with some type of scales?
Yes.
Yes.
A scale for depression and for anxiety also.
Okay, perfect. And there's also, for example, the Morisky scale for those who know about the adherence to medication. Type, great. So when you talk about the depression scale, you give this example, you have several items. So these items correspond to what, in your opinion? So you have depression and then you have several items, actually. So what do you think these questions, if you want, in the scale, or this what we call item or indicators in a scale represent?
Perhaps several things that are related, let's say if we're talking about depression, several things that relate to depression or different manifestations of depression.
Relate to depression. So you mean that cause depression?
Not necessarily, perhaps manifestations or different symptoms, signs.
Okay, that's exactly the answer. So basically in a scale, it is, if you want, when we develop the scale, these items, so we have the construct. So for example, as you said, anxiety, and we have our scale that includes several questions, items, indicators. So usually we call them items or indicators. And these are, as you just said, manifestations or signs of the construct. So to be more practical, let's continue with self-esteem scale. We have the Rosenberg self-esteem scale, which is a very famous scale. A lot of people have used it, okay? But it was developed in 1965, so quite a long time ago. And he developed it for just adolescent population. And his scale have 10 items or indicators. And basically, I'm just gonna go quickly over them. If you look at those questions, they are the manifestation or the signs of self-esteem. And how it was developed, so it took a lot of time to be developed. It was like a discussion with experts, and each one was just thinking, how can self-esteem be manifested in a person? And they started doing like some brainstorming, seeing the different, if you want, aspects of self-esteem, and like at the end they narrowed it to 10 questions. And this 10 questions it's a package. So you have to have the answer for this 10 questions to be able to have a score that will tell you if you have a high or low self-esteem. So just like an example here, the first question in this self-esteem scale is, I feel that I'm a person of on an equal plane with others. Second item is, I feel I have a good number of good qualities. I have a number of good qualities. Third item, all in all, I'm inclined to feel that I'm a failure. Fourth item, I'm able to do things as well as most other people. So if you can see, they're not exactly the same, or if you want, manifestation of self-esteem. Because if I have a high self-esteem, I think that I can do things that as well as other people do, right? If I have a high self-esteem. And also I would think that I have a number of good qualities. These two, for example, items, they're not exactly the same, because I also, for example, being proud, having a number of good qualities, it's not the same thing, but both are manifestation of high self-esteem. So this is how, if you want, the scale is constructed by item that basically shows are basically the manifestation, the signs of your underlying construct, which is a latent construct, which is an abstract construct. Okay, so far, is it clear?
Yes.
Yes.
Yes. Okay, I will continue. Okay, so basically this is what I was saying, that you just need to know that it's a package. So for example, if I want to use this self-esteem scale in my research, and I do feel that, okay, question number 7, it's not relevant for me, I just want to remove it, I can do this. I can just decide that, okay, I want to use the scale. And this is something that a lot of people, I had some medical students who used the scale, and then they just decided to remove one question because they felt it wasn't relevant, and they used it in their questionnaire. And this is totally wrong, because a scale, it's a package. So all the items are together to be able to give you a score of self-esteem. You cannot decide to play with it. You cannot decide to remove one item and use it. This is incorrect. It's the whole 10 items that basically you have to have the whole 10 items, the whole scores for all these items to be able to get a score and to be able to get a result about high or low self-esteem. Okay? Does it make sense so far?
Yes.
Yes.
Okay, perfect. Now, did you I'm not sure how I'm going to proceed because I didn't look at the recording, but just quickly, as you can see in this items, you have different directions. So for example, let's look at, okay, if you look at item 1, 2, 4, 6, 7, or if you want, compare 2 and 3, if it's easier. So here, 2, I feel that I have a number of good qualities. This is something that is basically positive. It's like, it is linked to high self-esteem. And number 3 is, all in all, I'm inclined to feel that I'm a failure. which is basically the opposite. It's linked to low self-esteem. So this is what we call the reversed items. So sometimes in a scale, you can have a question. I mean, it's basically advisable, and a lot of people would like to put reversed item, not all the item in the same direction. Can you guess why? I mean, one of the reasons. Can you like make a guess? Why do we usually in scale try to put not all the questions or all the items in the same direction?
To make sure that the participant like are focusing or concentrating, not just okay, strongly agree, you know?
Yes, exactly. This is one of the reasons. Perfect. Exactly. So usually we try to make it like different, as we said, what we call reverse item, to make sure that the participant not just entering Kif McCain, especially that a lot of في some scales that are basically self-administered, especially if it's kind of sensitive topic. We let the participant fill the scale alone, so they wouldn't be intimidated by the interviewer. And in this case, to make sure that they're not just filling it Kif McCain, we try to put those kind of reversed items. Okay. You're still hearing me, right?
Yes.
Yes.
Okay. Now, the second thing, one of the second point that were in this recording, that when we have a scale, so we know that it has several items which are basically the manifestation, that it's a package, and we can't decide to remove or keep one item here. It's the scale is validated as a package. And then basically a scale is validated in a certain specific population, specific country. So for example, this scale, Rosenberg validated it in adolescent in the US, I think, or I think maybe in the UK, I forgot. And if I want here in Lebanon to use the same scale, I cannot just, okay, he used it, I take it and I used it for adult population. This is wrong. If I really want to use a scale to be able to assess or to assess self-esteem, I need to validate the scale before. Even though it was validated in UK in the adolescent population, I need to validate it in the Lebanese population, even if it's the same population of adolescents. And if it's also another population of adults, I also need to validate it. So in a nutshell, any scale that you want to use, you have to validate it in your population. Of course, unless it was already validated in your population. For example, to the Morisky scale, which is the adherence medication scale, there is a team of researchers, I think, in LAU who already validated the scale for Lebanese population, for adult Lebanese population. If to do a research, I can use the scale because it has already been validated by another research group, because I'm using it in the same population, which is Lebanon and adults. However, let's consider it was not validated. It was validated just in the US. I cannot use it in my population. I need to validate it before. Is it clear? So the question...
Doctor, I have a question. When you validated on a sample or...
Yes.
On your sample of the study or a different sample?
No, that's a very good question. Not at all. You need to validate it on a different sample. So basically, validation studies are studies by themselves. So there are research groups who just actually conduct studies to validate the scale. And it's very important to do it on, it's actually mandatory to do it on a different sample. You do it on a sample, you validate it, and then you can use it for your research question. This is a very important question, and the answer is definitely not the same sample for many reasons. It could be also due to some statistical concern, but also, I mean, let's say that you try to validate this study, and to validate, usually you don't need a big sample size. There are some rules, but usually it's around 100%. And let's say that in your study, you have 1,000. And when you validate your scale, you discover that it's not valid, because it doesn't mean that you want to validate that's going to be valid. And we're going to discuss this later on. So you would have done this on a scale, on a sample size of 1,000, and it's all wasted because basically scale is not validated, not valid, you know? So you need first to validate it to make sure that it's a valid scale on a small size. And when it's done, then you can basically administer it and use it in your larger sample size for your research question. Okay.
Thank you.
Yes, Mira. I think you raised your hand.
Yes, hello doctor. I wanted to ask that there are some tools that are validated in Arabic in general. Can we use them in the context of Lebanon?
Now you have to see where it was validated, in Arab in general or just in one population, for example, Jordan. Case, no, usually you really want to follow the rule. No, you have to validate it in your population, especially if it also has an age range. For example, if it was validated among adults and you want to use it for adults, you need to validate it. So if you want a short answer is no.
Okay, in case if we're limited with time, can we use a pilot study to check, like a small pilot study to check its validity in our sample, or we have to conduct a whole pilot test to check?
Well, I know that some people do this. I know, sometimes, to be honest, literature, I've seen a lot of articles who are using a scale that was not validated, before in the population, and they're using it and they're just saying, okay, we did a reliability test. They're using it in the same sample beyond reliability test to be careful. There are a lot of actually publications I can share with you, publications who are using the same sample to validate their scale and to the hypothesis. But if you want, in theory, to be really correct, this is not the right thing to do. You need to do a small study. It could be a pilot study. I mean, sometimes 50 subjects is enough. Sometimes, to basically validate a study, and then use it for your research study. But a lot of, because they are short on time, because they don't really want to follow everything, by the book. They basically would do a quick pilot study, or just try to validate it, and quotation in the same time the actual study. But this is not how it should be. Now, in your case, if you are short on time and you want to use a scale and it's not valid in this population, now you can argue, you can see if it was already valid in similar population. You can put it as a limitation in your study. You said that, okay, we're using this scale, but it was not still validated in this particular population, but validated in like similar population. You can try to actually put it in the limitation. Or if you have time to do like a small pilot study with 50 subjects, also that would be ideal.
Thank you so much.
You're welcome.
Doctor, this also applies for a questionnaire that we develop, right?
No, scale are different than questionnaire. No, for example, if I'm talking about, let's say, a knowledge questionnaire about hypertension, and this questionnaire is not so, there is a difference between questionnaire and scale. So scale is when you have, so it was something that was validated, you have a score, and you have a cutoff, a threshold. And for example, this scale, self-esteem scale, when you have higher than, I think 15, you have a high self-esteem, sorry, if it's lower than 15, you have a low self-esteem. This scale, they did the studies, they did psychometric analysis, and they reached the point that this is a scale that can, if you want, I don't like the word label you, but can basically categorize people, individual, as low or high self-esteem. This is something that was validated. Now, you have other questionnaires and not scales that are basically, for example, a questionnaire to assess the knowledge on hypertension. But it wasn't validated. It's just a questionnaire that I decided to do to assess the knowledge of my population. And I decided to put a score. I mean, I decided to put 15 questions. وأنا قررت حتى average as a threshold. And قد إيه منهم they were able to answer more than half of the question correct. So in that case, it's a questionnaire, and I'm allowed to do it as I want. But I mean, it's not a scale. I tailored it for my population. There is no maybe comparability with other research because everyone can do their own questionnaire. It's different thing. A scale, if you want, is something that is very, for example, when you talk about depression, so you are basically categorizing people as depressed or not depressed. It's something that is really valid. It's as good as, and you're going to see that later on, as good as a diagnosis. Because when we do a scale, we compare it to, for example, a scale for depression, and we do sometimes for the same individual that you administer the scale, and then the same individual, they go to a psychiatrist who basically put if they are depressed or not, a clinical diagnosis, and then you compare to make sure that those who basically the scale labeled them or categorized them as depression are very close to those that the psychiatrist labeled them or diagnosed them as depressed. You see, so it's a very, a scale is something, the result of a scale is not just like a questionnaire that you made. It is validated with gold standard tools. You see the difference? Does it make sense?
Yes, yes, thank you.
Okay, so questionnaire and scales are very different. Okay. So when I was talking about scale that you need to validate it in other populations, so for example, this self-esteem scale is to measure self-esteem. It was basically used to measure the self-esteem of high school students, I think in the UK. But however, since its development, the scale has been used and validated with a variety of groups, including adults in several countries. So this is a more or less recent article, not really recent, 2014 article, where basically the author were just, their whole study was to validate the self-esteem scale in a Greek university students. So not high school and in Greek. So as you can see, the whole study is basically to validate this scale in Greek students and other students. Okay, so just to tell you that, we don't take a use scales and decide to put a scale in your study and consider that it's valid. No, it's basically, there are people who just do validation of scales to make sure that it's valid in your population before using it. Okay, I'm not going to go into this. This is just how we score, so the scores for a scale. So usually for example, in a scale you have usually Likert types, so strongly agree, disagree, strongly disagree. You can have score for each question. For example, here, strongly agree is 0. When you hear agree, it's 1. Disagree, it's 2. Strong disagree, it's 3. And for the reverse item, it's the opposite. And then you do the score for all the items so that each individual have a total score between 0 and 30. Okay, and then if you have more than 15, so if you have scores below than 15, so that means that you're categorized as having low self-esteem. Okay. So that's the concept. If you want, this is very, I'm trying to explain it in a very practical way, but when you will see the recording, it's more, step by step, smoothly going from the beginning, from the theory behind it. I'm just really trying, just because we're short on time and it was supposed to be more an application, I'm trying it to be very straightforward, just to tell you, the most important thing in a practical way. Now, another thing that you will see also in the recording is basically when we talk about a scale, as we said, we have the construct and we have here the X1, X2, X3, X4, X5 is what we call the manifestation or the items or the indicators, right? And one of the assumptions in any scale is basically that the shared variance or whatever make, so whatever make these items move together is just my construct, or here, for example, depression or self-esteem. So what we mean by is, and this in the recording, is basically that if my underlying construct, that self-esteem, is increasing by a certain amount, my indicator manifestation would be increasing or decreasing the same idea. So for example, if I have two people, one that has higher self-esteem than the other, manifestation would have basically higher than the other. So it's just the idea that all these items, their shared just linked to one underlying construct. This is something called unidimensionality, and this is a very important assumption in any scale. To go into it because in the recording you explained, but just to know that this is a concept that when we talk about scale, that all the items should basically have shared variance, and that this shared variance or the way they move is just linked to one underlying construct, which is in our case, for example, self-esteem, that they basically all share, they're all, if you want the underlying construct self-esteem, basically they all move together in a way. I'm not gonna delve into it because it's more theoretical concept and you need to see the recording to better understand it. Okay, so the second part that I want to use is when we talk about a scale, there are two things that we call psychometrics properties, which are validity and reliability. Okay, these are, so we're talking that we need to validate a scale. What do we mean by validate a scale? We need to make sure that the scale is reliable and the scale is valid. So do you know what does mean reliable and valid? I mean, these terms are basically very common in a lot of fields in epidemiology, in statistics, etc. And they all more or less mean the same. So if you take the concept, I mean, if you want to guess what does mean reliability, what does mean validity, and we want to apply it for a scale, on the context of a scale. Can you guess what do we mean by a reliable scale and what do we mean by valid scale? Just take it, try to guess.
Valid scale gives us accurate results, but reliability means that if we repeat the test several times, it will still give us the same results.
Okay, you mean reliability, it's consistency. So you repeat several times the same scale, it's going to give you the same result. Excellent. And the validity, what did you say?
If the results given are correct.
Are valid. So is it possible to have something that is reliable but not valid? So is it possible to have a scale that is consistent, give you every time the same result but not valid?
Yes, definitely, it is a possibility.
Okay, perfect. So exactly. The reliability is a concept of consistency. So if I'm using scale several times, so you have several concepts in reliability, several types of reliability, but it means it is consistent. It is, if I read the same test, I will have the same results, but it doesn't mean that this result is correct. So for example, for the self-esteem scale, I can repeat it several times and I'm still going to have the same result. It is reliable, but maybe the result doesn't really reflect my self-esteem. In that case, it wouldn't be a valid scale. It would be a scale that is reliable. It's mainly not self-esteem, maybe happiness, something else, you know. So you have to make sure for any scale, it should be reliable, but also it should be also valid. And it is also very well explained in the recording. But let's go to reliability. When you talk, so you said that it's consistency. It's the same scale that if we do it several times, we're going to have the same result. However, when we talk about reliability in the context of a scale, we have three types of reliability. The first one is internal consistency. The second one is inter-rater reliability. And the third one is test-retest reliability. The third one is basically something that is very, I mean, you all more or less, you're sure familiar with it. So test-retest reliability, if it's, I give the scale, I give a test to a person at a certain time, then after a few weeks, I re-administer the same scale to the same person, and I make sure that the results are going to be the same. Okay, this is a way to test the reliability of my scale. However, let's think together. What could be a challenge in this? So I'm giving a scale to a certain individual X, and after a few weeks, I'm re-administering the same scale to this individual. And just I want to make sure that in both time points, I'm going to have this result to make sure that my scale is valid, is reliable, not valid, is reliable. This would be called test-retest reliability. I would be assessing the test-retest reliability. However, can you try to guess what could be a challenge in this? What could be something that could affect this reliability? I mean, try to think out loud to guess. So if I'm telling you that I want to assess something, construct that change in time, what would you think?
Maybe the questions are not clear. Yeah, each one can understand it differently. Or?
Now, when you do a scale, basically, this is one of the points of a scale, and you're going to see in the recording, and it takes a lot of time, and you have to translate it and back translate it and administer to several people to make sure that basically it's well understood and that you won't have a bias in understanding the question. So no, let's consider that the scale, basically you make sure that it's clear, it's well translated, so you don't have an issue in the way people would understand the question. Let's say that it's not this issue. You already double checked it.
Maybe it's related to the person answering the scale.
Yes.
Maybe his mood is different or.
Perfect. Okay. So, I mean, it's not just about the mood. Sometimes the construct that so it's exactly, I think this is what you're trying to say. So let's say that I want to assess happiness, okay? And let's say that this happiness is something that changed, or my latent construct is something that changed in time. So if or for example, depression, you know that depression, it's not something that stays forever. It's temporary, it's a transient thingy. So for example, if people can be depressed up to 1 year, let's say. Some people are depressed for a few months. So if I'm using a scale for depression and I'm giving the scale to the first person at day 1, and then after 6 months, I'm redoing the same. 6 months is a lot. I'm just giving an example. After 1 month, I'm re-administering the same scale. Maybe this person is not anymore depressed. So in that case, I won't have the same result. And in that case, I cannot assess reliability. You know, so if I want to use retest reliability, I have to use construct, or I have to basically measure construct that are constant in time. Because if the construct from the beginning is not constant in time, أكيد they're going to change. So مثلا, if self-esteem, which is basically self-esteem, is not a state, it's a trait, it's something that is constant. So I can use retest reliability when I'm talking about self-esteem. But when I'm talking about depression or other construct that basically changes over time, I cannot do retest reliability, because I mean, maybe the person, as you said, changed this, what he used to be. I mean, he used to be depressed and now he's not anymore depressed. Is it clear?
Yes.
ممكن أقطع شوي بس. So the idea of retest reliability is that you can use it on the condition that your construct, yani what you want to measure, is basically something that is constant over time. If what you are measuring is not constant over time, أكيد ما هيطلع لكم retest reliability that is high. لأنه the person changed, the depression and the latent construct that you're trying to measure changed in this person. So this type of reliability, you just can use it if you're talking about a latent construct that is constant over time. Does it make sense?
Yes, it's clear.
Okay. Now, in inter-rater reliability, it's basically when you have one construct and you have two people who are trying, basically who are measuring, and you want to make sure that the reliability or the way these two people are measuring is the same. You know, for example, let's say that I'm doing some systematic reviews. Don't know if some of you took a course about systematic reviews, but let's say this. Now, this is not about psychometrics, but I'm just giving an example in a context outside of a scale. So I'm doing a systematic review. I have to go over 50 article abstract and title screening to make sure if these articles are included or not included in my review. But it is not just one person who is doing this, it's two person. And then I will do, so I have 50 articles with the first rater and 50 articles, the same 50 articles with another rater. And we want to make sure that both agrees on the articles that were included in the systematic reviews and those who were not included in the systematic review. So it's a way if you want to make sure that two people are rating the same article in the same way. This is what we call inter-rater reliability. And usually in a scale, we don't really use it. It's very, I mean, rarely we use inter-rater reliability. It's a type of reliability, but I mean, it depends of each scale. You won't see it in the scale literature, in psychometrics. You really rarely would see it, okay? what you mainly would see, what you would see in all scales is what we call the internal consistency. So I'm just going to rephrase it to make it clearer. Oh, sorry. I'm so sorry, I have a baby because, okay, so I'm so sorry for that. Okay, so what I want to say that reliability, we have several types of reliability, okay? Internal consistency, inter-rater reliability, and test-retest reliability. When we talk about scale, in the context of a scale, we always talk about internal consistency. This is something, Hala, I'm going to explain what it is. It's something that is, you have to prove it. When you want to validate a scale, you have to show that it has a high internal consistency reliability. This is the one, let me put it like this. This is the one that really is the most important one. In any validation studies, you will see internal consistency. Inter-rater reliability, it's rarely used in this scale context. Test-retest reliability, you might see it in some literature about scales if the latent construct is something that is constant over time, and you need to discuss about قد ايه بده يكون التايم frame between the first and the second administration. Okay, so what is internal consistency? Internal consistency in a very simple way, because now we're talking that about a scale with several items. For example, here in the self-esteem item, we have scale, we have 10 items. Internal consistency is to show or to prove that all these 10 items are basically in a very simple way, hang well together. So they are associated well together. They are correlated together to make sure that, for example, if this item will increase, this item will also increase more or less, they are correlated to each other. And to do this, we call several statistical tools to use something called Cronbach alpha. I don't know if you have already heard about it. Pearson correlation, intra-class correlation. It depends on the type of variable, but the concept of consistency is to make sure that the 10 items of the same scale are related and associated to each other. And this is something, when you want to validate a scale, you need to prove that it has a high internal consistency reliability, which means it has a high, that the items are well associated, are well correlated. Okay. Now it's a little bit tough for me to explain it because I was expecting that most of you would have, I was hoping that some of you would have basically seen the recording, because the way I conducted the presentation is on that you already know that. Trying now with the question to like kind of cover the concept that were in the recording. But so what you need to know that when you have a scale, you need to validate it, you need to prove that it has a high internal consistency, and which means that it has a high reliability. And the second thing that we were talking about, you need to prove that it is a valid, and we're going to talk about the validity. Is it clear so far? I know it's not very straightforward, but if already you get the big title, it's already good, because when you will see the recording, you're like, oh, okay, it will. So far for reliability, is it clear?
Yes, it's clear.
Yes.
Okay. So Khalas, in a nutshell, you have 3 types of reliability, and the first internal consistency is the one that you need to focus when you do scale validation. And how we do it, it's basically, so the concept is that the items are correlating, and you can do statistical methods to be able to prove that it has a high internal consistency, and using, for example, Cronbach alpha or Pearson correlation. Okay, the second one is basically validity. So how many types of validity? Now, there are 4 types of validity. The first one is phase validity. The second one is content validity. The third one is criterion validity. And the fourth one is contract validity. The first 2, phase validity and content validity, are validities that you cannot assessed statistically. They are more conceptually. So I took my scale and I wanted to, I'm doing it in a population in Lebanon. Okay, I want to validate it in a population in Lebanon. Okay, before this, you need to know that, let's say that I took the self-esteem scale and I want to validate it in my population. I have 3 choices. What could I do? Let's put them here. Okay, I have 3 choices. The first one, I can, what we call adapt the scale. So if I look at the scale and I find, okay, it makes sense, I translated it, back translated it, I think that the items make sense for my population, I can use it as it is, so translated, and try it on my population, on my sample population of 100, let's say, or 50 individual, okay? And then I need to test for the psychometrics property, which is reliability and validity. And I'll talk later on about validity. So reliability, mainly I will test if this scale has a high internal consistency reliability using, for example, Cronbach alpha. This is one thing. Now, second option, if I don't want to adapt, so the first one is basically, I'm gonna put it like this. New slide. Okay, option 1, it will be basically to adapt. So I have a scale, I just translated it. I feel, I discussed with expert, we feel that the content makes sense. I translated it back, make sure that the translation is correct, and I test it on a population. The second option would be basically what we call to adapt. Option 3 would be to assemble. So here, this is adopt. I'm sorry, and this is adapt. Okay. So the first one, so here it's to adopt. So I take it as it is. I just back translated, and I test it on my population. The second one is adapt. Adapt means that I took the scale, for example, the self-esteem scale, and I feel that some of the questions are not really relevant to my population. I feel that I want to make minor changes. For example, if I take a diversity, food frequency questionnaires, and I want to adapt the questionnaire, I'm not talking about the scale context. I'm just giving you an example in any kind of questionnaire. So I have a questionnaire about diet or physical activity that was developed in the US. So in the US, they have their main food, typical food. So for example, they're talking about, I don't know, bacon and stuff that are very familiar or very common in their context. When I want to use this questionnaire in my context, I would basically change the example of food. I would put, for example, hummus, مثلا باذنجان متبل, stuff that are more context, more adapted to my context, in Lebanese context. In this case, it's as if I'm adapting the questionnaire. So I'm making some changes in the original scale. There are minor changes just to adapt it to my context. This is the second option. If I can do it, I can do. So I take the scale, I discuss it with experts, I make some few changes to adapt it to my context, I translate it, back translate it, and test it in my population. And the third one is basically, I take the question, the scale, and I feel that really it's not, it's completely not relevant to my population. I want to basically either try to create a new one from scratch, or basically take several scales and try to mix and try to come up with a new one. So assemble is as if you're doing a new type of scale. And this will take a lot of time, and it's a long process. You discuss with experts, you do brainstorming of possible questions, and you really try to build or construct a new scale, and then you try to test it in your population. So if you want, when you have a scale, these are the 3 approaches that you can do to be able to, and before validating any scale in your population. Either you take one that already exists and you just adopt it just by back translating, making just the language, the correct language, and you test it in your population. Option 2, you adapt it, you make some very slight minor change just to make it adapted to your context. And the third option would be no, you really try to make major changes. You're basically trying to construct a new scale. Okay, so that's, if you want, the first 3 steps. the first options that you, يعني إذا بتكون من الأول, this is what you have to decide. Then once you decide on one option, you need to, and you build your scale, you need to test it. Okay, how we test the scale, whether you adapt or assemble, you need to test it. As I told you, to test a scale, you need to prove, or you need to test the psychometric properties of the scale, which are reliability and validity. Reliability, I was just telling you, you need to look at internal consistency reliability to make sure that the items within the scale correlate well, they hang well together, and you can do it by using statistical methods like Cronbach alpha. This is one. You can also try to retest reliability if you have a latent construct that is constant. This is one. Second, you have to prove that this new scale is basically valid. And this is where we reached this point. So to prove that the scale is valid, you have the face validity and content validity. These are conceptual, and criterion validity and construct validity, these can be proved statistically. I'm going to start with the last two, because basically when you adapt a questionnaire, you use these two. When you more assemble one from scratch, of course you have to start with face and content validity. So I have my scale. I want to validate it. What can I do? I can validate it with a gold standard. So in my sample, when I was talking about depression, I give them the scale about depression, plus I also, the same subject, they can go I can bring a psychiatrist to give a clinical diagnosis for the same subject, and then I can compare the results. So if I have a good, the result of my psychiatrist, basically results plus of the scale are comparable, are quite correlated. So I can consider that my scale is quite valid, because I had answers that are quite similar to the gold standard, which is the psychiatric diagnosis. Does it make sense?
Yes.
Okay, that's it. Now, basically, we run out of time. I'm so sorry, really, before the validity head part. I really wanted to be more like interaction and a question answer, but I had to change. So I'm trying to explain it through the questions. But I'm sure that if you feel that it's quite complicated, I'm sure 100% that when you will see the recording, everything will be very clear. This is if you want, just like a big picture of it. And construct validity, it's basically if you want to make sure that your scale, so it's a concept, I cannot explain it in 5 minutes, but it's another way that statistically you can prove that your items are basically measuring the same thing and are measuring. So for example, if I have a depression scale and I want to make sure that the different items are loading together on the same factor, which is depression. This is going to be very difficult for me to explain it now, but I look at the recording and it will be very well explained. So I'm going to stop here. We still have just 5 minutes. What I want you to do, if you want, because I feel really have time to look at this question, at this recording now. Some of you, I think, are interested to work or to basically use scales. From your question, I understood if you are planning to use scales in studies, right? If this is the case and you have any question related to scale, please, Anja, don't hesitate. Just email me and we can have a one-on-one session to discuss what to do with your scale, how you can basically test for the validity and for the reliability of the scale. It's a horse itself. And even in the recording, Sarah did not go into the statistical way. She's just talking about the theory behind it. But if you have, in this case scenario, you have a scale, you want to validate it, please don't hesitate to contact me. We can have one-on-one session and we can go statistical way if you want to validate a scale. But what I hope I did in this small presentation is just for you to get familiar with the fact that, okay, you can choose any scale anytime you want. You have to validate it. And what do we mean by validate a scale? Make sure that it's valid and to make sure that it's reliable. And for this, you have to actually use a new sample, not just a sample of your study to test for this. Is it fine? What do you think about this approach? We do it like this. I will keep it open to your if one of you is interested in validity reliability. What we do is either next session. I mean, you watch the recording till next session and we do them together, or if some of you are just interested, basically they can contact me and we can have one-on-one meetings. That sounds good.
Doctor, concerning next session, it's an application on validity and reliability, or
no? It was supposed to be about application on biases. I was planning to give you articles about case control and cohort and just discuss what are the biases. It was just exercise application because I know into hala you have your exam, so it's most of my sessions was supposed to be basically application. Just the first one was a lecture about DAGs. And the other two, I was planning to do them just application. So today about DAGs and about validity reliability, and next week it would be about biases. However, I wasn't, the thing about validity reliability, I don't think that Anjad, you grasped the concept because the way I prepared it, it was just question answer based on the fact that you already watched the presentation. But because it's very, I totally understand that you're overwhelmed and you had a long weekend and it's very difficult for you to watch the recording. So I'm trying to see with you, what do you prefer? If you're really interested in this topic, next week, we can basically go over it. I will do it as a lecture, not as a practical exercise, and as a lecture about scale validity and reliability. And we don't go over the biases. If you, what do you prefer, Into?
For me, doctor, I prefer to do it on biases as planned, and we will watch the recording. And if we want any question, we can get back to you, as you said. Because
yes,
I think biases is more like we encounter biases more in our articles more than validity or I think that.
Okay. And for the other, what do you prefer?
No, I agree with Mahmoud.
Okay. Okay, you all agree, because I know two people they asked me about scales and if they want to validate. So please, particularly these people, إذا عندكم أي question about validity and reliability, خاصة إذا أنتم in your project عندكم a scale that you want to validate, I'm gonna راح أحط my email على news forum. Please, Anjad, don't hesitate to email me. We can have a discussion. بكون هيك case by case in your case شو هو scale and how to do it, because صراحة validity reliability يعني نحن أخذينه as a course, it was like 3 months. Okay, it was very intense, it's very big, it's very long, and even هتشوفوا بالrecording تبع سارة we don't delve into the statistics. It's just a theory about what we need to do to be able to validate a scale. So إذا أنتم بدكم to delve أو بدكم to actually do the statistics, or you want actually just to know about it by curiosity, I can have a one session with you and we can go over them. Sounds good?
Yes.
Yes. Yeah.
Okay.
Thank you.
Thank you all, and I'm sorry Hexar for the validity reliability part, but I think it's fine. It's totally normal هيك يصير. Given the fact that you have your exams and it's a very overwhelming period for you. So I'll see you next week, So next week, basically, I'm just going to give you don't need to prepare anything. I'm going to give you articles. If you want ahead of time, you can have a look, read the articles a little bit. I go over them. A little bit, just the method part. And what we're going to do together is to try to analyze what are to identify the biases of these articles. So just look at the method section and try to discuss what are the biases in the article. So you don't need to prepare anything. We're going to do them together in our next session. Okay.
Okay.
Thank you.
Okay.
Thank you so much, Doctor.
Thank you so much, Elkon.
Thank
Yalla,
you.
have a nice day.
You too. Bye bye.